Hi, I'm Jay Pongonis from HXGN TV, and today I'm going to be speaking with Patrick de Groot from IMAGEM in the Netherlands. We're going to be talking a little bit about change detection and how that is moving from two-dimensional to three-dimensional change detection. Thank you, Patrick, for joining us.
Thank you.
Can you tell me a little bit about IMAGEM, your company, what they do?
Yes, of course. IMAGEM is the Hexagon geospatial distributor for Benelux. So that's Belgium, the Netherlands, and Luxembourg. And we are a 100% Hexagon geospatial focused partner. So all we do is use the Hexagon geospatial technology in various arenas in our territory.
Okay, can you tell me a little bit about change detection? It's been around for a while. Can you tell us what some of the typical uses of change detection are?
Sure. So change detection in our sector is used primarily for, let's say, the base registration maintenance. So we have these base data sets that everybody is obliged to maintain, and it includes housing footprints, for example, or dormers being detected, and that's what we use change detection for, to automatically detect how these footprints have changed and how they should be incorporated into the data set.
Okay, so how is the technology, how are the uses of this evolving today?
What we see happening is a move from 2D change detection to 3D, so including height in our process.
Okay, why is that change happening?
Well, I guess it's around the basic notion of the fact that everything we do outside is in fact 3D. So it's actually kind of strange that you would do change detection in 2D when in fact the things you're looking for have a third dimension. So now that we have the capability to create 3D data, we should also use it in these processes.
Right, so if someone adds a floor to a building, right, that wouldn't show up in the building footprint, but it would show up in 3 dimensions.
Exactly, yes.
So where do you get suitable 3D data?
Well, there are multiple sources you can get it from. First off is LiDAR. LiDAR is very accurate, so it's a very good source for doing change detection. There is a little bit of a challenge there because it's quite expensive to get it in, so to acquire it, especially when you want to do it year over year or even more frequently. And with change detection, that is currently the span that we're looking at least once a year, and we might even want to do it more often than that. So if we want to have a different source, we can use stereo imagery these days. We're capable, with the technology that's around, to create very dense point clouds, 3D point clouds, from that data and use that for our change detection process, and that works very well.
But even with this, with LiDAR data, with photogrammetric point clouds, there's a very specialized knowledge required with that. How do you get around the need for that specialized knowledge?
That's a good question. It's true, it does require specialized knowledge, but the good part is that the technology on the analysis side allows us to create models, spatial models. So those models are created by people that have that expert knowledge, and by the time we're done with that, the end user simply has to push a button which invokes the model, and the actual technique is running in the background to do the change detection. So all they see at the end is the end result. And they simply can go from situation to situation and determining if a change that has been identified is actually significant in their process.
So that cuts down the time from acquiring the data to getting the actual result.
Oh, absolutely, absolutely. We're now able to, let's say, automate about 80% of the change detection process. So that part is being done by a computer, and the last 20%, which always has to be done by a human being because it's all about interpretation, that's the only part that resides with the end user. So that's a great savings opportunity.
Okay, so we've kind of been talking mostly about real estate applications. What other kinds of applications can benefit from 3D change detection?
Oh, there are a lot. If you only look at, for example, the defense arena, where we use 3D data to simulate an operations environment, 3D data is almost inevitable to be really sure about the area you're going to be dropped into. But also in a civilian workspace where we use 3D data to come up with city models. And let's say you have a new development coming on. You want to be able to put that new plan inside your existing environment to see what it looks like, determining shadowing, things like that, or solar potential even. All those kinds of applications, they require 3D data.
Okay, good. Now, where do you see the future of these techniques going?
I will see that future to be more and more 3D. I think we're moving away from 2D as much as we can. And really, the fact that the technology allows us to automatically calculate 3D data, along with the fact that the hardware that's needed and the processing capability becomes less expensive, that all adds up to a more positive business case to create the 3D data. And I think when we look back in a few years' time, we will wonder how we ever got about using just 2D. I mean, it will be 3D and even 4D and 5D over time. Yeah.
Okay. Would you have anything else that you'd like to add?
Well, maybe if anything, I'm amazed at the speed of which our technology evolves. I mean, if you look back 2 or 3 years even, we were nowhere near the capabilities that we've got today in automating these processes. And it feels like we've only scratched the surface at this point. So I'm very excited about what's in store next. And I can only anticipate more and more applications.
Great. Thank you very much for joining us. If you would like more information, please visit the website imagem.nl. And if you would like to watch more episodes or learn more, please visit hxgntv.com.